All right, thanks. We're going to get started. So welcome to February's meetup. I'm Jason, the organizer. Thanks again. Tonight we're honored to have Tim from Databricks discussing Delta Lake. So it should be a very interesting talk. Before we get started, I usually just like to thank our sponsors. There's also a tremendous amount of food out there. So if you want to eat, I know you can't bring it in, but if you want to sneak out and eat, and that'd be much appreciated. So I don't have to take all the pizzas. So we will be raffling pizzas. So Variant Technologies is a larger defense contracting company. They've been worthless for several years, helping us. They support the local agency, system engineering, software engineering, data science. What's kind of interesting about them is they're getting into some of the Amazon autonomous racing, and we're actually going to have a talk in a couple months featuring one of their leads. And they actually have their own racetrack, and they're going to release the code, and they're going to let you guys actually upload code to their car and let it ride around. So I'm trying to figure out where I'm going to do it. It actually might be here, but stay tuned for that. Clarity, I know Ryan's here. Do you want to say hi, Ryan? Yeah.
Hi, I'm Ryan. I'm with Clarity Business Solutions. We're a smaller defense contractor. We do fun software development.
That was excellent. So he didn't know I was going to do that, so sorry, Ryan. Next Century is now CACI, but they're a larger defense contracting company also. They do various things up and throughout the coast. If you're interested in learning more about them, you can talk to me. Arius Ventures is my company. It's on my hoodie. So if you're interested, you can talk to me. I don't have as many words because we don't do as much stuff. But we try. So next month, I've already announced it. It's going to be the data journalist from the Baltimore Sun. So it should be pretty interesting to see like how they actually work and how they're working with the newspaper and what kind of information they're working with. And then in April, I didn't really know how to list this, but it's his name's Jim. And he's actually really affiliated with like the open source community. And he's going to give a talk on like how open source has evolved and his involvement in Apache and kind of related to everything that's going on with current industry. After that, there's a lot of speakers coming, like Amazon, the Amazon Racer. There's going to be a talk on blockchain. So some very interesting things in the next couple months. There is a newsletter. If you're interested, news at dataworksmd.org. I usually give away stuff in those newsletters. So we just gave away a free pass up to the Riley conference in New York. I'm giving away a 4-day pass to a data science course that's actually worth about $4,000. There's only about 40 people signed in. All you do is you do a questionnaire. So if you're interested, I would suggest find that and you can sign up and you have a chance to win. If you're interested in speaking, talk to me. If you're interested in sponsoring, talk to me. And if you have experience running conferences, talk to me. I am trying to do a conference, looking to do it in August. It would be at APL, so I'm in the early planning. So if you have any experience, I really appreciate it. I could use the help. So with that, I'm going to hand it over to Tim. Tim is a solutions architect at Databricks. He's going to wow you. He said you can ask questions throughout. Very last thing, I have a lot of stuff to give away. So what I'm going to do is at the very end, usually I say if you ask the questions, but if you're interested in the t-shirt, just come up. I have about 5 books to give away. I have a ton of DataWorks shirts. I have a ton of Databricks shirts. I have a ton of stuff to give away. So come and get stuff so I don't have to carry it in my car. Thanks. John's the reason we always get the venue. He's our APL host. Let's give him a round of applause.
Couple more happens. All right, good evening. Really excited to be with you guys. I've been coming to this meetup for a few years, on and off, and really appreciate what Jason does to keep the lifeblood flowing here in our area. So tonight we're talking about Delta Lake, which is a technology that's built to run in conjunction with Apache Spark to make it better. So just a little bit personally, I've been working in this space for a little over a decade. I worked at Booz Allen for a few years. I see my Booz Allen Alumni Club and these board members here tonight, as well as another small contractor after that for a couple of years. And while I was there, I really pivoted hard into, instead of just doing stuff at the desktop level, I started writing things in Spark. And it was a ton of fun, and it really whetted my appetite. So when the opportunity came to work with Databricks, it was really enticing. So Databricks, just for context, the same 6 original creators of Apache Spark spun off Databricks as a company to make it ready for the enterprise. So that was in 2013. So we've gone from 0 customers then to over 5,000 today. And so I'll minimize what I say about Databricks in this presentation, try to make it about Spark as an open source technology, but you will see some Databricks artifacts as we go through this. And plenty of swag to be had afterwards for both, as Jason mentioned, for Delta. Cool. All right, so as far as the agenda tonight, we're going to talk about this idea of a lake house. You might not have heard this before unless you go on vacation, but it's going to apply to our data tonight as well. And so then we'll go to the motivations for a lake house, challenges people have in building modern big data pipelines, introduce Delta Lake as a solution for that, talk about how it works. We'll look under the hood a little bit without putting you to sleep, show you how easy it is to get started, go through a really cool use case that we'll watch a video from about 5 minutes from a major telecommunications provider that they did at Spark and AI Summit last year. And then lastly, I'll go to a demo as we go through a notebook and show you kind of how you operate with Delta Lake. Okay, this is an awesome slide. I love this. So there was a blog post on our company blog 2 weeks ago today by the folks mentioned up there at the citation. So just, again, for context, so Ben Lorica is a guest writer with us on this one. So he's the chief data scientist for O'Reilly Media, and also organizes the Strata conferences. So Michael Armbrust was the original creator of Spark SQL, and then Ali, Reynolds, and Matei were 3 of the original 6 creators of Spark. Right, so these guys have been in this world, seeing it all over the world, and they're pretty well qualified to speak. So what's this about? Well, the Cliff Notes version is, so if you came into the data world in the 80s, 90s, early 2000s, how'd you get your data? Well, you went to a database, and which is great because there's a nice schema. It's easy to write SQL against it. You get exactly what you expect. It's fast usually, unless you wrote too large. Right? So the oracles, the Teradata's, make that work very easy for people doing simple reporting. But as data started to increase in volume and velocity and variety, data warehouses became something that were increasingly hard to manage and not flexible enough to do things people wanted to do. For example, documents and images, right? They don't really fit in a data warehouse. And then typically with those data warehouse providers, you're paying a lot of money for them to manage the infrastructure. And so if you have petabytes of log data, for example, that's not really a great fit to dump into a data warehouse, and so you're going to leak money out the wazoo. So the idea of a data lake with like Hadoop, starting in 2005, took over. And so this gave you a lot of flexibility. It gave you cheap, commoditized hardware, open source software, so your costs of operation went down. And you also saw the rise of things like MapReduce, so that you could write more serious machine learning code, if you like Java, right? And so there was the ability to do more with your data. But at the same time, you lost some of that nice, neat, contained data that you had with data warehouses. And you couldn't expect your transactions to complete. Like if you've ever written MapReduce or pig jobs, what happens if you wait for 4 hours and then it doesn't finish? Anybody been there before? Okay, it's pretty painful. So that's not a place you want to be if you have people depending on that data downstream. So, fast forward to 2020, we now have some other tools in place to help us get the best of both worlds. So things like Spark came along, starting about 2009, 2010. Spark's sort of taken over from Hadoop as the de facto big data processing standard, which is great. But even with Spark, there have been some gaps. And so Delta's going to step in and help us fill those gaps. Okay, so why spend so much money going to data lakes? Well, people have this vision, right? They see like the Facebooks, the Amazons, the Googles making a ton of money with data. And so everybody wants to do it. So whether it's customer data, web data, text, video, audio, all this stuff has value in it. And so I can hire a data scientist and I can throw them at my data lake and they can get value out, right? That's the vision. And so that's a great skill set to have as a data scientist, right? It pays well, it's lots of fun, and you can just go in your data lake and get value out. Except that, if you're a data scientist and you're part of a data project, what's your first pain point? Getting the data, right? So of course you can write code. You go on Kaggle, you pull up a notebook, the data's there, you can build out your model, and you're a rock star. You make a blog post. But what if you go work in a company and that data is already clean for you? Well, yeah, most data is not clean, not ready. So what happens is your data is not reliable and these projects fail. And the money, and the data sits there by the terabyte, by the petabyte, and it doesn't get used. So why? What is it that causes so many reliability and performance problems? All right, here are a few. So just to help me tailor this a little bit, who's used Spark before? Just raise a hand. Okay, good. Hive? Okay, good. What else? Pig? Okay, good. So I actually came into the data world after Hive became a big thing. After that became a big thing, I came in right to Spark, so I kind of skipped that step. But I hear it's really painful. And so there are a variety of reasons why your jobs might fail. In one place I worked, there were network outages all the time. And when you're streaming data into your cluster, and then you're writing a Spark job on top of that, and then the network goes out, and your job is waiting for the data to show up, and then it chokes. Yeah, so you get data written to a table that's partially there. You have analysts waiting on that on the other end with an analytic they've written, and then they see like the volume drop, or they don't see what they're expecting. They get upset at you, and that's not a good place to be. You have to go back and delete stuff, blow up your partitions, rewrite the data, and that's not a happy place. Schema enforcement, this comes up too. So if you don't own the entire pipeline, which usually you don't, people upstream from you can make changes to the data that then will affect your jobs downstream. So if someone inserts a new column, they change the name, they change the type, or data is just malformed, and your job is expecting a certain schema, it will also fail, and it won't finish. Or you'll get mixed schemas, and when you go to read it out, you can't get a guarantee on reliability for that data. And then consistency is another thing. So for example, if you're using Spark on Hadoop and you're writing to a table and you try to read from it at the same time, it doesn't work so well. And likewise, if you're doing batch and streaming mixed, that also doesn't work so well. So you need something that allows you to have consistency between users, between jobs, and also concurrency. Okay, performance problems. Anybody heard of the small files problem? Right. So in a nutshell, small files, when you're reading, you can spin up a cluster of tons of workers, and you can point it at, all of your Parquet or ORC data, and you start to read it. If those files are small, you pay a fixed overhead to read out each one. So even if you have lots of workers, you're going to pay a price to read it. It's really slow. On the opposite end, big files are slow to read because you can only put one thread on them at a time. So you try to read those out, and no matter how many workers you throw at it, it doesn't matter because you're going to be locked on a single thread to read it. So you're going to be somewhere in between. Partitioning. So partitioning is great, when, especially if you have tables that have pretty well-defined reading patterns. So if someone or some analysts are almost always doing filtering based on a date, right? And partitioning on date is a great idea because you can skip entire chunks of your data directory to do those reads based on the date that's been specified in the query. But let's say that this is actually something I've seen with one of the customers. Let's say that they partition based on the load date, but that's not the same thing as the transaction date. So the analysts are looking to query on a date that's transaction date, but the load date is something entirely different. Then they lose those benefits. So if you pick the wrong field, you don't get the benefit at all. Or if you pick something that's too high cardinality, you again don't get those benefits. So lots of reasons and things to be careful with. And then if you have to correct your partitions, that's painful. It takes a lot of time to rebuild your whole table. And caching as well. So this is something that's come into play in the cloud when you read data out of S3 or Azure Data Lake storage. We're reading the throughput directly out of those systems isn't especially fast. So if you're hitting that over and over again, you're paying a price unless you cache it somehow inside the local compute nodes. All right, so for all these reasons,
Can you explain that? You got 50 VS 200. Which? Oh, DSL. Can you go back? So, you got SSD is 300 megabyte per second. And then the other one, core. What is the core?
so that's like the worker node that you're pointing at that's doing the read out of, in this case, I think this is for cloud storage, so probably S3. So it's a lot slower to read it out of S3 versus reading it directly from like a memory cache.
SSD is not memory.
This is 20 to 50 megabytes if you're reading from S3 per each CPU core, whereas 300 megabytes per second if you're reading from local SSD per core. So it's faster to read from a local machine than from a remote storage.
Okay, thanks.
Thanks. That's why I brought Seth to Geary. So I'm glad you're here.
You have a clicker.
Doesn't work. I wish. Okay, so for these reasons, so Databricks, right, there are several of us, Antonio, Seth Geary, Ben, where'd you go? All right, so as solutions architects, sort of the first lines out in the field with customers. Over the years, selling Spark, people learned to put a lot of hacks in place. And so, anytime people go to production with Spark, before my time especially, there's just a whole host of things people would do to try to get around these issues. And it just became, layer upon layer of things that it's a waste of time. So, smart engineers, way smarter than me, developed this idea of Delta Lake to help some of our largest customers solve these pain points. And so they made some choices when they created Delta Lake. For one thing, open source. Open source is one of our core values as a company, and it had to be important, it had to be in place for Delta as well. So Parquet, does Parquet ring a bell for people? Right, it's a columnar data storage format, so it's great for wide tables where you only need to look at a few columns at a time. So that was the choice of underlying data format inside Delta Lake. Transactions, so essentially ensuring that when you write data into a table, you get all the method. Right? You get some guarantee that the data is going to be ACID compliant. And then the other thing that was important was you didn't want to create a whole new framework that had a new language you had to learn, right? Because that's just, it's going to be a hard sell. So it all meshes neatly within the existing Spark APIs. So if you're using Scala, using PySpark, then you can just continue doing that. And I'll show you some code snippets later that show you what it looks like doing it using Delta functionality inside of Spark. Okay, so in a nutshell, what does Delta Lake do? It solves those reliability and performance problems so that your data scientists and your BI users and your decision makers and your CEO, so they can all be happy with their investment in a data lake. All right, now we'll go under the hood a little bit. Any questions, I guess, before we move on?
When you say transactional, can you build like your regular type transaction type DBs on top of it? Is that what you mean, or
Can you give me an example?
like a banking system, banking type?
Yeah, so think OLAP, right?
Yeah,
so
yeah.
batch analytic processing.
Yeah.
Yeah,
Yeah.
but,
So can you do OLTP on it, or?
I mean, you sort of can, but it's not ideal because you want to be working with bigger data sets. That's where you get the efficiencies. Except if you're anything you want to add. Yeah. Okay, so what are the key features Delta adds to ensure more reliability? So ACID transactions are really important so that you have exactly what you expect in your table so that multiple users can read from it at each time and then they get a consistent view. And so that the data also is persisted to disk in a way that allows it to be durable. Schema enforcement, and I'll actually add to that schema evolution. So that again, your data is in the structure that downstream jobs are depending on. Unifying batch and streaming. Does anybody have any streaming use cases in their jobs here? Yeah, okay, I see one hand over there. All right. Yeah, so if you go out to California and ask that question, you'll get a lot of hands up, but here it just hasn't really come yet. But out in the industry, especially like in retail, in manufacturing, you do see a lot more streaming. So Spark was written to help those folks, Delta, but it'll help you too. And the last thing, this is really cool, you can actually travel back in time with Delta, so you can keep versions of your data without having to make versions of your data. It just happens naturally as you write continuously to the table. Okay, so that's reliability. Performance. So one thing to call out here, and I'll show you more about this in a minute. So Parquet, right, is the core data storage format. But what Delta adds to it is a transactional log that makes it easy to figure out exactly which files to read, as well as some statistics. And when it keeps statistics, it's sort of an implied indexing, so that you can skip partitions, you can skip files based on the conditions of the query you submitted. So what that means is you're not doing full table scans, and you sort of get some of those relational database benefits, but because you have those sort of inherent indexing. Compaction. What Delta does to sort of balance the small and big files problem is it tries to make a uniform size per file that is optimal for both reads and writes. I think it's at 128 megabytes per file. And that's just sort of a rule of thumb. It seems to work really well. And then caching, when you're running this in Spark on Databricks, you get the additional benefit of having your data cached in those SSDs. So that way you're not paying that price to read it out of cloud storage over and over again. Okay, so in practice, people start using Delta Lake. What do they do with it? So one of the nice things about using Spark is the flexibility of the APIs. You can read batch, you can read streaming, you can have a hybrid cloud on-premise environment where you're reading from, say, Oracle or IBM database on-premise. All those sources can feed into a common data layer. And what we usually call that's the bronze layer. So it's raw data, doesn't have any guarantees about being validated, being formatted correctly. Right, so it lands there, then you start to run your Spark jobs on top of it. And so that first layer, I mean, this is sort of an approximation. It could be like 10, 15, but in a nutshell, you have your bronze for the raw, silver for data that's refined, and that's trusted. but maybe big and not normalized yet. And then you might put it into some gold layer that's condensed so that your CEO can get a high-performing, I don't know,
Can you
like
explain Parquet?
Parquet.
Yes.
So Parquet is it's a binary data format that's based on columns. And what's nice is it's splittable, so you can take, unlike say JSON, right? If you take a bunch of JSON files and you save them all, there's no guarantee that you'll have the full schema, whereas Parquet is sort of self-contained. It tells you everything about the schema for the data in that table. You don't want to look at it with your human eye, though. You'll need a reader tool because it's binary. So yeah, the silver layer is trusted, and then you have the gold layer. You might even have a platinum layer, so that it's really condensed and easy for people to use for reporting, even for machine learning applications, and that's where the magic happens. Something else to point out too about Delta is that it doesn't, at least in theory, it doesn't matter where you store it. Right? It just has to be a place where you can control the data storage from it. So you can't dump it to a relational database, but you can dump it into Hadoop. Right? You can put it in, whether it's Azure, whether it's Amazon. You can even run it on your laptop. Right? So you could just store your data in Delta format on your laptop. And if you go to the keynotes from Spark and AI Summit last year, so Michael Armbrust, who's the creator of Spark SQL, and actually the lead engineer for Delta Lake, he ran a demo that was just all local on his machine. So it's pretty cool. Obviously, Databricks we run in the cloud, but Delta being open source, you can take it, you can run with it, you can build it with Scala locally and get a feel for it there. Okay, so a little bit more under the hood, and then we'll pivot back out and I'll show you some applications. All right, so if you say Delta to disk, like if you ran it on your desktop, on your laptop, and you wanted to poke around at your data, what would you see? So you'd pick a directory for your table at the top level. And if you look at the bottom, so you know this, I'm colorblind, so is this green?
Yes.
Yeah, okay, good. So yeah, the green layer, that's the actual data in Parquet format. And it could be broken up by many partitions, or maybe you don't need partitions and it's all just sitting at the top level. What Delta adds is this log, where each of these is a commit, it's a transaction, which has one of several types of actions in it. And I'll show you what those actions are. But what can happen with this is, especially if you're doing a streaming job, or you're maybe committing a file every 5, 10, 15 seconds, and you're running this continuously, you get a lot of files in here. So Delta needs to have some other mechanisms to handle that scaling of the metadata and the data at the same time. So how does it do that? So the table is a set of actions. Each of those files has things like either change metadata, meaning I'm going to change table name, a field name, I'm going to change a schema, I'm going to add a column, I'm going to change a column type, change the partitioning. But, so if you look at like the distribution of those actions, the vast majority are going to be add a file, right? Because usually you're just appending it to a table over time. If you're changing metadata a lot, then you have bigger problems, right? So you don't want to see too many of those. And remove files, that's a cool Delta feature that you can't do with most Hadoop operations, where you actually want to delete data. So you can do very surgical deletes out of Delta. Okay, yeah, so that's the way, so operation 1 might be, I'm going to add those 2 Parquets and commit 2, I'm going to remove those 2, add a third one because maybe I rewrote the table and I deleted a few records that were spread across the first 2, but then I added some others, so I'm just going to blow up those first 2 and I did one. Okay, so some of you might have been a little dubious before when I said you could do concurrent reads and writes and concurrent reads across multiple users, batch and streaming. How does that happen? So Delta's optimistic. So it's going to treat users as though they can all write until proven otherwise. Okay, so it's called optimistic, solving conflicts optimistically. So in essence, it's going to try to let every job finish, but when a job goes to actually make the commit, it'll check to see if any of the files that you need to touch in your commit were touched by any of the previous ones. So if someone else beats you to it, and there was a file touched in one of those other JSON files before you, then it'll kick your job back, right? So it doesn't write anything until it knows that the path is clear, which is kind of cool. And really, in practice, this works well because if you have two people or two jobs that are trying to write the same data at the same time, again, you probably have bigger issues to solve. So usually this works well because processes tend to be isolated. All right. And I mentioned before, too, that there are definitely use cases where the number of files, the size of the table gets huge. We have customers doing this at the scale. In fact, the original customer that motivated this, they get, what, trillions of transactions per day? Is that right? And
Petabyte in it.
yeah, petabyte and a half of data. So how do you work with that? Spark itself is actually used inside of Delta to do all the scaling with the metadata, to figure out which files to read, right, which files to delete. All that is done and executed in a Spark plan. So yay for open source. Okay, so now enough of the conceptual stuff. Let's get real. If you wanted to start using Delta, all right. Okay, those of you who've written in Spark, which API do you like to use? Python? PySpark? All right, Scala? Oh, that's so sad. SQL? Spark SQL? Okay. So here you're going to see both Spark SQL and PySpark. That's what's going on here. So first, you can actually do it in either order, but first you need to create a table. So it gets registered in the Hive Metastore. So you create it using Parquet, and then you specify schema, say a location. Great. Then you can take your data frame in Spark and write out to that location that you specified in your DDL. All right. So how do you think you do it in Delta? What does it look like? Looks like that. The only thing that changed is literally swapping out Delta Parquet for Delta, and that's it. So as far as learning new tricks, there's not a whole lot to learn. I'll show you some things that are different, and I think you'll like it. Okay, so if you want to convert from Parquet to Delta, convert to Delta, and then Parquet, path, anything schema-wise you want to inject. And that's it. So then the Delta engine will go ahead and make that conversion for you and create the JSON files and the statistics to make your data more reliable, more performant. And then there's an optimize command as well, and that's the one that takes the files, whatever size they are, and tries to bin pack them into the 128 megabit or megabyte ideal. Okay, this part's awesome. So if you've worked in the data warehousing world and you can do updates on tables, but when you went to the data lake and you couldn't, this is kind of the lake house thing right here, right? This is now I'm working on data at scale. I'm treating it like I would in data warehouse. So if you're working, say, Hive, and you want to update a row, like one row, you have to blow up the whole partition when you write it. But with Delta, you can make a very surgical update based on match conditions. So, and the fact that you can do it through a SQL API is even nicer because people can read this and understand what's going on. So you can even show it to like your boss, who maybe was the DBA back in the day, right? He's going to get this, so that's good. Okay, yes, time travel. We do it. So what does it look like? The only thing here that's going to be different is now I can add an as of clause to my query and specify either a timestamp or a version. I'll show you when we get to the notebook what this looks like. But in essence, when you make all those commits, Delta keeps the transaction log, and so it knows which files are present at each time, and so it's going to read based on which files were actually there. And so this is really handy, especially if you make a bad commit and you don't know quite when it happened. You can roll back and incrementally check, figure out which timestamp was the one that you want to roll back to. Then you can make that your fresh data again, your current data. Okay, story time. All right, so this is one of the keynotes from Spark and AI Summit this past year. So this was the team at Comcast. Anybody use Comcast for their home entertainment? All right. It's Comcastic. So they have the X1 voice remote, right? And so can you talk to it? Right. So when you talk to it, it's actually taking that voice data. It's going to send it back to wherever they're hosted in the cloud. And it's going to, of course, translate that, figure out the semantics of it, and then execute some action based on whatever you asked it. Okay, so how does all that happen in the hood? Well, they have a lot of smart people on their team. They've used a lot of tools, tried a lot of things. And I'm going to let them tell the story of how they landed on their architecture. So I'm just going to show you the part that's really the data engineering part. The machine learning part is fascinating and would be a great topic for another night, but for tonight we're just going to see the data engineering piece. So I'm going to go to video. Hopefully this will work.
Thanks, Jan. So I lead our product analytics and behavior science organization at Comcast. And what we do is build rich data sets that help make more informed decisions. We build these rich data sets by taking explicit events and building implicit context. So in our voice example, it's taking what a user said and trying to figure out what they actually wanted to do. So we do this taking billions of voice sessions, petabytes of content and telemetry data, and build this rich data set, all while handling millions of transactions per second. So I'm going to walk you through building this pipeline of where we were and where we are today. So to build out this, we need to do sessionization. We need to do a multi-hop enrichment process. So first thing we do is we do an ingest job. We take these hundreds of different event types, we combine them into a flexible schema so that we can further sessionize this. In sessionization, we need to take and do a sort order and take all of the events by timestamp and then try to make a classification based on what happened before and after these key events. We take this and then further push it downstream where we enrich it with all this metadata and then optimize it for downstream reads. So let's see how we deploy this at scale. So when we take this, we run this through our pipe, we ingest it, and we go to write this to S3. And this just fails. So when we looked into it, we were writing 15 million transactions per second. So S3's limit is 3,500. So we knew we had to get to work to scale this. So the first thing we did is we called up AWS and we started talking with them, like, how do you fix this? So they said we have to do this random prefix. And the struggle for us was that random prefix, it needed to sit above the partition structure. So when you go to read, you're going to basically be doing an equivalent of like a full table scan. So that wasn't going to work. So we worked with them, we built this custom bucket with this key structure with then these partitions sitting behind it. But it was pretty ugly, but it worked. So it allowed us to move forward and get to our sessionization, which is the key thing we really wanted to do in building this value. So when we did this, now we have these small files we have to deal with. And it was a struggle. So what we ended up doing so we could deal with the memory issues and the shuffle and the garbage collection tuning is we made 32 concurrent runs of the same code. And it allowed us to scale, but it was enormous. So these 32 concurrent runs were 640 machines, i3-8XLs. So to give you some facts on that 640 i3-8XLs, that's 143 terabytes of memory and 2.5 petabytes of storage. So this was a really, really big job, really expensive, and it had to be super durable, and it was a little bit of a struggle to scale this. So writing this out to S3, we further optimize it, we do joins, write this out, and it just got really complex. And when it failed, it was a struggle to update. And we knew we could do better. So there were 3 things we really wanted to solve for when we were going to update this code and build this new pipeline. Is we needed to deal with scale. We wanted S3 to scale, and we wanted it to be a lot simpler. We needed to be reliable, as data was super important to our organization. And we needed to make sure that when they ran queries against it and used it, it was going to be accurate and timely, and that they were going to get the right answer. And it needed to be performant. When you're scanning this much data to solve problems, you have to make sure that people are going to want to use it. If the queries take way too much time, the value is really diminished for us. And I'm glad to say we solved this problem using Databricks Delta. So let me walk you through how we updated this pipeline using Delta. So the first thing we did is we moved our first job to streaming. It really created a lot of new opportunities for us. And we could also do a streaming join, further enriching the data before it gets to sessionization so that we can make more classifications and be more intelligent about what we're doing when we get there. So writing this out to S3, a huge problem for us, previous key management, and I'm glad to say we can solve this with 1 line of code in Delta, enable random prefixes. No more key management. But small files were still there, and it was still a problem. So what we did is we used auto-optimize, and that just cleans up our files. It makes them the right size that Spark wants to have, so that downstream reads are a lot more performant. So going and building sessionization, 32 concurrent runs of the same code was really annoying. It was really difficult for us to manage, and if any of those failed, it was really hard to recover from. And I'm glad to say, with Delta, this turned into 1 single job and 64 machines. So 640 to 64 was a 10x savings for us. So that was huge.
All right, we'll pause there. So, pretty cool story, right? So it's a 10x savings in infrastructure, data's getting in faster, and really, what Delta adds, it's kind of simple, right? You're adding statistics, you're adding a transaction log, but doing that correctly, you can have immense impact on your organization. All right. So what I hope has come across as we've talked through this tonight is that Delta kind of merges these 2 previous worlds that we love for different reasons, right? That you have the reliability, the structure, the ease of use of a data warehouse with the flexibility, the scale, the horsepower of a data lake. Right? We'll call this a lake house. So it's an exciting time, like I said, to be in the data field. Certainly working at Databricks, we see Delta Lake a lot. We love it. I hope it's something that you consider trying if you're experiencing any of these pain points around data. So I think that's the end of the slide content, but I'm going to show you a short demo of what this looks like in practice. All right. So yeah, a little context real quick. What you're seeing here, this is a Databricks notebook, and it's connected to a running cluster in the cloud that has fully provisioned with Spark, with a bunch of machine learning libraries. So it's not Yarn, we have our own resource manager that manages that. It's the best Spark experience. Okay, taking the Databricks hat and go back to the talk. It's a really easy platform to use. I see some of our customers here tonight. I hope they would agree. But what's nice about this as well is you can go poke around for free on our community edition, and I'll give you a link to that at the end of the talk tonight. So the things you do in Jupyter, any Jupyter users out here? Awesome. Okay, so like all the keyboard shortcuts are going to be the same. You can do magic commands, like the things you're used to that are convenient in Jupyter, you can do here as well. Plus some other cool stuff, and that's the topic for today. All right, so what we're going to do is just compare and contrast how Delta works versus just a plain Parquet table. Okay, I'll skip over some of this preliminary stuff and just essentially giving some data locations. This is data that's sitting in S3 buckets that have been securely mounted to the cluster, right? So that cluster has access to those and can read data in, write data back out. Okay. So what I'm going to do here is read in this Parquet file. This is open source loan data. Going to read
Can
it.
you zoom out of,
Zoom out.
zoom in.
Zoom in. Yeah. Command. Is that better? More?
That's it.
Thank you. Okay, so the gist of it is here. I'm just going to do Spark, read, Parquet, load a data source. I'm going to save it as Parquet in in a project-specific directory. That's the magic here. I'm going to take then that Parquet table. I'm going to load it through the Spark SQL API and create a temp view called loans Parquet. So nothing too complex happening here. I apologize to those who have not used Spark before. I will try not to bore you with too much code, but there's just a little bit. I hope it's readable enough that you know what's going on. All right, so let's wait for this guy to finish. The rest of the commands will run faster. All right, so if I go look at this table I've created, I'm just going to, again, use the Spark SQL API, select star from that view I just created, and here's what it looks like. So very simple table, 4 columns. It's not really big data, but that's okay because we're just trying to be fast and agile tonight. Yeah, another view on that data. Okay, so how many records does it have? Let's run this one. Select count star from loans Parquet. This is a Spark data frame, 14,000 records. Okay, not big data, but let's follow the story. Okay, what I'm going to do now is create a generator that's going to run a Spark streaming job. So it's going to essentially take the same structure as that table we just made, but now add some random rows to it. And it's going to stream and append those to the same table. So that's all that's going on here. So I create a function to do that. And then this. And I'm going to kick off a streaming job. Give this a second to warm up. All right, and so it's writing, I think it said 5 files per second. So what's going to happen with the files that get written? Be small, right? So it's not going to be great for performance. We can use Delta to help us clean that up later in terms of optimizing. Okay, so let's see if the data is being added to the table. Remember when I first started this, I had a table that was 14,705 records. When I read it now, it's 200. So what happened to my data? Okay, this is where it gets fun. When you're trying to use Parquet for streaming. All right, so you can see now, remember the old table had 4 columns, now I have 6. So when you run Spark streaming, it puts these 2 fields in by default, timestamp and value. And yeah, so now I have 2 different schemas. So when I read it, I read out the data with the new schema, but it didn't infer the data with the old schema. So it left out those 14,000 records and I only got the new ones. So that's not good, right? If you have people depending on this data, and now Spark is not giving you what you're expecting, right? That's bad. So how do we solve that problem? Let me skip some of this stuff, and I'll show you how we solve it. Right, so Parquet did not do schema enforcement, and it didn't handle that batch and streaming workload mixture. All right, so what we're going to do now is the same thing, but we're going to take that same data, write it into Delta, and then try to kick off a streaming job and write that into Delta as well. Okay, so very similar code. What's different? The key word is Delta, right. Everything else is pretty much the same. All right, and what you're waiting for here is S3 to do its thing, right? So I'm deleting prefixes in S3, I'm deleting data. That's the delay here. It's not so much Spark. Anybody, we're waiting for this, is anybody developing Spark applications in the cloud? Okay, someday, we'll see lots of hands. Yeah, sorry, I was learning this earlier today and I ran it for like an hour, so a whole bunch of files got written, and that's probably what's happening now is it's deleting all of those. All right, well wait, we can just proceed. So when I go into account again, I'll see the same that I originally wrote with the batch job. And I have the same format, the same schema as before. Still deleting. All right, sorry, this is the perils of demoing live. We'll kick this one off. What I'm going to do now is read a stream out of that table as I start to write it. And what we find about that is because you're using the Spark Streaming API, this select count star is actually going to update itself over time continuously. Man, that's slow. All right, the joys of working in the cloud. I guess we'll wait for this. Any other questions? Anything about the Comcast video? Yeah.
Yes, I had a question about the Comcast video. So you still have 1.5 petabytes coming in of live streaming data, right? And you still have to write all that to S3 buckets. It seemed like that's still what they were doing behind the hood. So how does Data Lake really solve that problem for them? You're still writing the same volume. And if anything, like you say, it's now version. So you have to keep the old data that you maybe modified because your data is blowing up.
That's a good question. And I'm actually not sure how they got around that pain point. Any of you guys know?
The question is, how do you write so much data?
Because there was a problem before with what, 15 million? I think it was transactions though, right?
Oh, the 1.5 billion write sessions, they were writing it like just files. They were writing too many small files and blowing up the S3 break. Now what we did with auto compact is before you write the files itself, it's going to compact it and then write it. So you have far fewer files, same volume of data. Right?
So it's landing in memory, not on disk first, is that right?
Yeah, first it's going to compress in memory and then write it down. Right? The challenge with S3 is the number of transactions, not the throughput. S3 is almost like a dump truck. It can move a lot of things, but it can only make one trip, fewer trips at a time.
sorry for the delay. This doesn't usually happen. Any other questions? Yeah.
Good question. So you said that it basically breaks them down into 128 megabyte files, and it gives them a random prefix. So like, let's say I have a terabyte file, and it's going to break it down into multiple files with a random prefix. How exactly does it read that? Does each of those, like, let's say like 9 files, so they all have the same like base with a separate random prefix in front of it? Like, how does it know that all those go together? Because it's breaking down big files. It's easy to make small ones into bigger ones, but if you're breaking big to small,
Right.
then I'm just sort of curious how that works.
I'm pretty sure that when he says prefix, that's a S3 convention that goes to the directory, but not to the file name itself. So when you write out the files, it's going to be like part-0 something when it writes those out within the prefix. So it's like within a directory.
Okay.
So they all roll up to a prefix.
Okay.
Yep.
So would you count microservices, like web services going to query, would you count that as streaming?
So can you give an example of what you mean by microservice in
Well,
this
I
case?
mean, you have processes going, and queries coming in, and then every query has different microservices on it, and then it goes and hits, and then it's all happening. Does that count as a streaming thing, or what?
So we think of streaming usually as being the write process, more so than the. I mean, you can do a streaming, you can put a listener on a query, but usually that needs to write, like it has a source sync concept when you do streaming. So it's not like a dedicated. What's that?
You're saying it's a write process?
Yeah, because you're going from a source and you're writing it out to a sync, and then that sync's maybe listening and sending it to a
What
different
if
sync.
you're doing queries?
Yeah, right. So actually, I'll show you what that looks like here in this example, right? So you can make a query that'll continually listen. In fact, that's what's going to happen here.
It's cheap and bold. Yeah, just cancel that and change the path.
Yeah, we'll do that.
Quick
Thank
question.
you. Yeah.
For Spark SQL, that is ANSI, so you can still use things like analytical functions, things like that.
Yeah. Absolutely. Okay, we're back in business. Thank you. Great idea. So now we wrote that batch job. We should see 14705. There it is. Great. Same, like I said, same. Is out of the way. Same schema as before. Now, this did not work. Let's try it again. All right, wait for that count to pop up, and it should be a streaming count. All right, so it's 14705. Let's try to make that change. So we're going to kick off this generate and append data streaming and put it to that delta path that we just specified, and let these new records get appended. Aha, it didn't work. Why? Schema mismatch. Remember when we do the streaming job that it inserts those 2 extra columns. So how do we fix that? All we're going to do is take a subset of our columns to the ones that we know match the schema. Right? So this prevented us from corrupting the table. We can make the change. And now we can kick this off again. Okay, so now it's running. And we can watch. Let's watch this number. It's exciting. It's like watching grass grow, except it will change. There it goes. Okay. Cool. Now we're up and running. Also something that doesn't work in Jupyter. This is a Databricks functionality. Okay. We can even add another stream, keep adding more and more data to it, and have fun. I can also query it as a batch job, not a streaming job. So essentially, if I query as a batch, I'll get a snapshot of the table at the time that I query it. All right. So we'll stop all these. And let's say that now I want to change the schema in a way that is intentional. I want another field to be added. And that's close. So what I'm going to do now, when I write to the table, I'm going to do mode append, like before, but now with this option of merge schema true. And when I do that, it updates. Remember when we looked at the JSON files of the transaction log, and it has the option to change metadata? That's what's going to what will happen here. So now when something reads that Delta table, it knows that the schema has changed, and it'll sort of retroactively work that out with the data that's there before that didn't have that schema. So this is really nice. All right. Any questions on this part? Yeah.
Sort of facetious question, but you've got 4 columns, of course, like you said, it's not big data. What happens when we get into like 1,000 columns? How would you do that in what you just did with appending the data, adding columns, deleting columns, things like that? Especially if you let's say that do 100 columns at a time on like a database that had 1,000 columns.
You're saying to write the code to do it, or to?
Yeah, I mean, how would you? Yeah, the code basically. Like, how would you do that?
Yeah. So I was actually working with a customer this week that they have a table that's 1,750 columns wide, and each one's like a custom code to write that in. Version control, I guess, is the answer. Like you got to make sure your code's right and use good CI/CD. Hopefully you can, I mean, Spark does help to make this somewhat modularizable. Like if you have custom code that you do a bunch of times, you can create like a UDF that wraps a bunch of that functionality into something simpler and efficient, so it can make it more readable. But in general, I think we would just try to advise good CI/CD practices. I don't know if you guys want to add anything. Yeah, it's hard, right? I mean, at the end of the day, it's still work, even though you have these cool tools.
I mean, I think maybe like a custom code to read the column headers and they could create it. It's probably.
Oh yeah. Right. Yeah, that's a good idea. Okay. So what did we see that was good about Delta? We could do batch and streaming at the same time. We handled schema enforcement. We evolved the schema to add that new close column, and I've asked a transaction. I didn't have any of those streaming jobs that wrote partially, but then failed. Okay, so a couple more cool things, and we'll wrap up. So deletes, right? So deletes are great. So for example, GDPR. Does that come up for anybody? Okay, I mean, not so much if you're working at Fort Meade, but if you're working out in like the financial sector or retail, right? E-commerce, right? GDPR is a big thing. And so this was something that was important, is that if someone requested to have their data taken out of your data stores, you need an easy way to do it. And so Delta is going to make that possible. All right. So let's say in this particular example, we no longer care about loans that have been fully paid off. So what I could do is, within this table, just delete anything that matches this condition. The funded amount equals paid amount. Right? So again, really simple, easy to read. Kick this off. Rewriting two files for delete operation. Updating the table state. All right, so 13 seconds. Let's see if there are any of these left. No, they're gone. Right? Same table, but we went through and picked up the files that had record vesting criteria, marking for deletion, wrote new files in their place, and now you have your current records match exactly what you intended to do. So that was cool. Real quick, so audit history. This is important as well if you want to know who's messing with your data, and you want to know what operations were done. Or you want to try to figure out how far back in time the last commit was done. You can do this, this table history, right, exposes that for you. So that's what it looks like. Time travel. So, okay, this is kind of an ugly way to expose it, but what I'm trying to do is figure out when was the last commit. So I get that from this line. I'm going to take that previous version and put it here. So version as of previous version, and load it from there. So I'm going to go back one version, and I should see about 5,000. Before, yep, there it is. So I can go back to before I deleted those closed loans. Right? It's still there if you really want it. But if you don't want it at all, the operation you want to do is called vacuum. Right? Makes sense? So if I vacuum, that data is really gone at that point. It's deleted completely. It's not just marked for deletion, but it's expunged. Okay, let me pause there real quick. Any other questions? Yeah.
The time travel data, how long does that stay in the system? Does it stay indefinitely until you do a vacuum?
We had a good conversation about this recently, of how long you want to keep data for. I think the default in Delta is 7 days. Is the default? Or is it 7 or 30? 30? Okay. Now you can, in theory, keep it forever. You might eventually see some performance degradation, but people do all kinds of things to go to keep old data and archive it. So, I mean, you could just let it go, and go, and go, and go, but you're going to have a lot of you sitting in S3. You may not want all of it. But the default's 30 days. And then it auto vacuums at that point. Yeah.
Is it possible to vacuum up just a single transaction, like in your GDPR example, right? You want to vacuum up that delete of the user, but you want to leave all the other add things in there.
I believe it's continuous, everything before a certain time. Correct?
You can't pick and choose what you want to vacuum. Only certain one. That's the point.
That's interesting. I mean, I can see a reason why you might want to do that. Yeah. Yeah. Great point. Anything else?
So basically, you're saying it's best to, instead of relying on the deletes sticking around the lake, it's probably better to have an archive. So if you're dealing with like NetFlow data, let's say I identify this computer, but it's a Chinese and they're making it look like it's mine. So I say, hey, get rid of that. That's not important. Let's pull it off because it's not in whatever we're looking for. Then we realize it is. Now we just lost all of our historical data. Or like you said, we risk the possibility of degradation of the entire data lake.
Right.
So I guess the only solution to that really is just like a backup.
Well, so one of our big customers that does the cybersecurity use case does just that, where essentially they will take it, when they want to vacuum, they'll go back to the point in time when they're vacuuming, grab the full history before that, and just take a snapshot and dump it out in Parquet somewhere. So you have like an as of some date. And so if you need to go back, like to look for some malicious actor that was there a long time ago, you could do it. Right?
Now what, when you snapshot it like that, just to guess, like what's like the file size of the snapshot? Are we taking up like a whole petabyte with the snapshot? Or?
Depends on the use case, right? So, like NetFlow can get pretty big. I worked with that in the previous one. It was, there you go, yeah.
Especially with NetFlow and a, gigantic,
You probably want to do
enterprise
it,
network.
probably want to do it as incremental. What was your previous backup? What was the delta since then? If you have the time points, you can do that. I wonder if you can use S3 lifecycle analysis as well.
Yeah.
Page up,
Page up.
share, that kind of things.
Yeah.
So again, everything we store is on S3. You can use your other object level management features of S3.
Or Azure.
Yeah, all right.
Yeah, great point. Okay, home stretch. So I think backing is pretty intuitive. I'll skip over that part. Upsert. Yeah, this is important. Right? We talked about that code snippet I showed you when it says when matched, then update, when not matched, then insert. That's what's going to happen here. So it's a merge operation. I'm actually going to, let's run this part. Let's do it. This will be quick. All right, so I'm going to look for just a small subset of nodes. I'm going to take this particular subset and change them, and then go put them back into the bigger table. Okay? So it's kind of a synthetic use case, but it'll get the point across. So I think there's just, like 3 records here. Okay, so we'll just manually doctor it up by creating a new data frame in Spark based on those 3 records. So we'll just build it from scratch. So, ID2 and ID3, we're just going to make these changes to them. So now, right, and this is my new data frame. It's a little bit different than the previous one. So I'm going to merge it into my original Delta table. Just using this syntax, right? I'm going to do .merge. Again, this is the Python API. If you're using the Spark SQL API, it would look a little bit different. So .merge, and then when matched, update all. When not matched, insert all. Right? Pretty straightforward. So I'm just going to update the records that are different and insert the ones that are new. Okay. So when this is done, now when I query that table and we look at those first 3 load IDs, right, these are now the new values. So I've updated my table. And I think that's pretty cool. All right, last stop, then we'll be done for the night. So, any machine learning fans out here? Come on, I know you're out there. All right, so this is kind of a dumb use case. It's not really a good one, but it's going to show you how machine learning is interchangeable, works seamlessly with data. So, I'm not going to build the model here. I built it previously, persisted it out to S3, and then read it back in. So it's just a simple create a boosted tree model in Spark based on the same data. So I will say, if you look at this data, right, like, could you really get much insight out of here with machine learning? I don't know, right? There's not a whole lot of a story to tell. So before I do that, I'm just going to kick off my streaming job. Okay, so let's kick this off. Okay, so now we have our stream writing back to that delta table. I'm going to use that for machine learning. All right, so read this model in. I can expose the stages of it. It actually, I built a pipeline, so it does like a string indexer on the state field. One hot encoder puts all those together with the numeric value and then feeds it to a GBT model. So pretty standard, basic machine learning pipeline. I'm going to write a little helper function here that just takes some data frame, adds a closed column because my model expects a closed column in it based on this conversion. This just says whether the loan's been paid off or not. And so now I can take that. Oh, sorry, we're going to use this one. So yeah, I'm going to add the closed column. I'm going to transform the model using that pipeline. So now it's going to take the fitted model, predict whether a loan is closed or not, and then I want to see how accurate the model is. So I'm going to compare the label and prediction columns that I get from from applying the model. I'm going to compare those to each other and see how accurate the model is. So what that now is going to look like is I'm going to kick off and do Spark, read stream, delta from there. I'm going to transform and score it, and I'm going to make just a simple confusion matrix on top of the stream data. It's kind of fun to watch it, right? Suspense. Wait for it. Okay. That's weird. Okay, well, some data that was there before isn't there now, so that's why I have my confusion matrix. Right, that ruined the punchline, but it was working like a champ earlier tonight, so anyway, sorry about the rough landing, but the point is if you, let's say you're doing the A/B testing, right, and you are watching users' reactions to something you put on your website, you could, and you've click streams coming in, and you want to see, do they like the old or new site better? You can actually visualize this in real time using Spark Stream. So I think that's a pretty powerful thing, not just in e-commerce, but you could look at this in cybersecurity context, right? There's lots of applications here. So, so anyway, I hope what you've gotten out of this tonight, we'll wrap it up here, is just to say that Delta does smooth out a lot of those rough points that we see with going to put putting big data jobs in production. And it's really easy to get started. So I will just close by going back over to a few links. I can share these with you. I don't know, Jason, if we can send these out. But yeah, so the blog, the Delta homepage, open source Delta. The notebook I used, actually, you can get it from that GitHub site. That's the link to the video for the Comcast talk. And then if you wanted to start using Databricks to do any of this stuff, that's a link to our community edition. So with that, any other questions? Yeah?
Does Spark implement a lot of the same machine learning algorithms that say scikit?
Yeah, actually they look almost identical. It doesn't have everything, but the vast majority do convey over. So if you used to like the dot transform, the dot fit methods, most of the same algorithms do convey over. Someone might be able to tell me which ones don't. I forget. But yeah, the vast
Well, it's
majority.
kind of the idea here is that if you're using Spark, you have something which is interfacing to like Hadoop or like big data already. Or
Right. So what's nice is you can take the stuff you've been doing in scikit-learn and change very little structurally in your code, but now you've pointed at a much larger resource.
okay.
So that's the difference. Yeah, great question. Yeah.
I might just have a question about, So I've dealt with Hadoop running through like Apache Spark, and then you run it through Tableau for, like you said, like a live streaming of like network, predictive and descriptive analytics. Do you have any other preferences for like the final portion of it for display?
Yeah, that's a great question, and one that a lot of people want to do. So if you go back to the link house diagram, right? So you see this BI box, like that's like where most people go to do their analysis, or in the BI tool itself. So yeah, Tableau, Click, Power BI, Looker. Yeah, okay, Looker. I work up at CMS most of the time, and SAS and MicroStrategy are big players there. So all those, the short answer is JDBC or DBC to connect to Spark. And so then the data, now, I mean, there are nuances in which ones work better, but in a nutshell, they all kind of go down that path. Yeah, and what's cool about this is now, it's not like you're waiting on some extract, it's just like a subset. You can actually read entire tables through Spark and pull back a condensed result into a live connection. So it's very different from waiting on someone to ship you a file and you load into Tableau, right? So it's really cool.
Now with Delta Lake, so I've got a heavy net flow coming in, petabytes and petabytes and petabytes.
Right.
I mean, really, is my only option to make a cutoff and choose, deletion or vacuuming based off of what's not needed anymore? Because at some point, the more data you have, which is sort of a conundrum, the more you enrich it, the better your model might become.
Right.
But then, you start to run out of space, and then it gets clunky. So I just didn't know if Delta Lake took that into account, or how it dealt with that.
So I'm working with another customer right now that kind of faces that issue where they want like a highly performant data warehouse that doesn't have all the data, but then they do want like a true curated data lake where they can go back and build models on everything. And so you can do that, right? You can have a subset that's for operational stuff, and then you can have another subset that's for longer term things. And so we see how people doing it that way. Storage is cheap now, so you can pull that off. As long as you can just be assured that you have the same data in both places. And because Delta has ACID transactions, you have guarantees that you have the same things in both places.
I was just asking because if I'm running a lot of log files that are maybe like a kilobyte, and Delta Lake's turning them into 128 megabyte files, I mean, that could end up being a lot. I mean, yes, storage is cheap.
Right.
I could still, exponentially, it could increase my operating costs by like millions of dollars, depending. That's sort of why I was asking. Particularly if you're looking at like low kilobyte sensor data or net flow, stuff like that.
So that's where writing it, taking it as a streaming job and writing it out into a Delta format with 128 meg gives you that, right? You kind of avoid that pain point of writing all the small files in the first place. So using like a Kinesis or a Kafka solution, if you can save you that pain point. Were you going to say something, Seppi?
No.
Okay. You're looking very wise. Okay. Anything else? All right. Well, thank you for your time tonight. And we have swag.